Now let's look at a very high yield topic, and the high yield topic is the common ion effect. It's put into so many conceptual questions that it's really good to understand this. So we're just going to have a surface level example and then a very detailed quantitative example below this. But so let's first talk about what a common ion is. So a common ion is just going to be an ion that is introduced into solution from two different sources. And what is that going to do? Why do I care if I have an ion coming into solution from two different sources? Well, the common ion effect is that if an ion is introduced into solution that is already part of KSP, it will cause the molar solubility of the ionic solid to decrease. Here's the key point here. And you might not understand it right away, but we'll be working on understanding it. KSP is not going to change, but the molar solubility of the ions will change. So if I have the equation KSP is equal to, let's say here we have HCN, I have H plus and Cn minus, well, I have some set KSP value. So this KSP value is not going to change. And so if I already have a solution that's at equilibrium, I have the maximum amount of H plus and Cn minus dissolved into solution, what's going to happen? Well, that's not what I meant to say. So if I already have the maximum amount of H plus and Cn minus dissolved into solution, well, what's going to happen when I introduce more of one of those ions? Well, what's going to happen is, let's say I have HCN and it's at equilibrium with its H plus and Cn minus ions. So I'm at equilibrium every time an HCN dissolves into its ions. I have an H plus and a Cn that is dissolving, or that is precipitating, back into solid HCN form. And so great, perfect, there's an equilibrium. But what happens if I introduce NaCN? Well, Cn is already a part of the KSP expression. And so if I increase the amount of Cn, well, what's going to happen? Equilibrium is going to be thrown off. I'm going to have too much of this variable, and it's going to cause me to precipitate more HCN. I need to account for that change to get back to equilibrium. So this can even be thought of as Le principle, which is if you have too much of one reactant, you're going to shift equilibrium to the left. And so as we shift equilibrium to the left, that would be us precipitating some H plus and Cn, and that would be us decreasing the solubility. We're taking these ions out of solution. So we're decreasing the solubility. Now, that is basically the gist of it, but I wasn't really happy with this until I had a quantitative example. So if you're comfortable with this, skip this next part, go on to section 16.5, and we'll meet up there.